Today we're going to do dilations. It's a type of transformation. We've already talked about two different types of transformation. One was translation, where you moved the entire object like to the right or left and up or down. All right? Every point went 3 to the right and 5 up, or that type of thing. The other type of transformation we've already talked about was reflection, and that's where you reflected over the x or reflected over the y. So if you reflected over the y-axis, you times the x-coordinates by -1. And if you reflected over the x, you times the y-coordinates by -1. Dilation is a different type of transformation, and then it either enlarges or reduces the figure by a scale factor. The scale factor we've already talked about. It's a scale that doesn't have units because both of them are the same. Each number has the same units. Here's how I help students remember dilation is if you've ever heard the word dilated. Right? Where might have you heard that word before? The eye doctor. What they do is they dilate your eyes. They might put something in your eyes that dilates it. That makes it larger. They also might do something. But just because your eyes are dilated and make them larger doesn't mean that it's always going to be enlargement. For this homework, sometimes you're going to reduce the figure. Okay, and you'll figure out here in a minute, we'll talk about how you're going to know if it gets larger or smaller. Here's what you need to do. You need to copy all of this in your notes. And then what you need to do is you need to graph this on your graph paper. That's going to go in your notes. So I would write above the graph paper example number 1. And then we'll talk about it. So we need to graph 2, 4, 2, 6, 8, 6, 8, 2, and then you need to graph the dilation, and it has a scale factor of 1/2. So here's how we do that. What I'm going to do is I'm going to go through each point. Okay, so J is at 2, 4, so we need to find J prime. Well, here's what I do. I start with the original units. The x-coordinate of J is at 2. So I take J prime, the x-coordinate is going to be 2, and I times it by the scale factor. So I take 2 times 1/2. And then I take the y-coordinate of J, which is 4, and J prime is going to be 4 times 1/2. What is 1/2 of 2? 1. Okay, anytime you divide by 1/2, or times by 1/2, it's the same thing as dividing by 2. So 2 divided by 2 is 1. What is 1/2 of 4? 2. So there's J prime, 1, 2. So this is what's expected. This is how you show your work. K prime. The original was at 2, so I times it by 1/2. The y coordinate was at 6, so I times that by 1/2. 1/2 of 2 is 1, 1/2 of 6 is 3. That is K prime. M prime. M's at 8, 6, so I take 8 times 1/2 and 6 times 1/2, which gives me 4, 3. And then the last one is N prime. So I take 8 times 1/2 and 2 times 1/2. Okay, make sure you're timesing these. I had students get confused. This is multiplication. We multiply every coordinate by the scale factor. So that gives me 4 and 1. There's my coordinates. So now that's what I'm going to graph. So let's graph J prime. It's at 1, 2. K prime is at 1, 3. M prime is at 4, 3. And N prime was at 4, 1. Now we can connect the dots, okay, which I just gave an example. This is what it should look like. So let's see if it looks like that after we connect the dots. Does it look like that? Yes. Okay, now it said the scale factor was 1/2, which means 1 unit on the small one is 2 units on the big one. If you're not for sure if you did it right, compare this from J prime to K prime is how many units from here to here? 1. How many units is it from J to K? 2. So would that be right? This is 3 units. 1, 2, 3. So how many units should this be? Is it? Yes, it is. So you must have done it right. Right? So, and it's the same shape. It's the same direction. Right? The only thing that changes is it's much smaller. Okay, any questions how to do that? Okay, write this down. And then you're going to draw this, and this is going to be example 2. So it says the triangle has these vertices, those corners, A, B, and C. You're supposed to find the coordinates after dilation, and then you're going to have to graph it. So let's figure out what A prime is, and what B prime is, and C prime. So A, the original was at 1, -2. So I take the original x, which is 1, I times it by the dilation, which was the dilation. 2. And I take the original y coordinate, which is -2, and I times it by the dilation, which is 2. So A prime is what? What would be the coordinate? 2, -4. Okay? Make sure you pay attention. If you're times them by negative, it's going to be negative. As long as if it's opposite signs, it's always negative. B prime. The original was at 0, 2. So which I take 0 times 2, and I take 2 times 2. What does that give me? 0, 4. Good. C prime. It's at -2, -1. So I take -2 times 2, -1 times 2. -2. Okay, and then graph it. Let's see if this looks like the object, just smaller or larger. A prime was at 2, -4. B prime was at 0, 4. And C prime was at -4, -2. And connect the dots. Does that look like the original? Just larger? Yes, it does. So did anyone notice like how we're going to know if one's larger or if the dilation is going to be smaller? Anyone notice yet? Right, we just did one, right? The one we did before, was that one smaller or larger? Smaller. And what was the dilation? A half. What's the dilation here? 2. And this one got larger. So here's how we know if it gets smaller or larger. Write this down. Here's the scale factor, and this is what I was talking about. This is what I was hinting at. Hey, if the scale factor, which they're just calling it K, that's just a variable they're going to use. Right, K, it's an enlargement if K is larger than 1. We had a scale factor of 2, which was larger than 1, and so it got larger. Our object, what we were drawing, the dilation got larger. On the first problem we did, K was a half. Our dilation was a half, which is less than 1, and it got smaller. And then if K is equal to 1, then it's the same. It's not going to change. So that's how you're going to know if you're going to draw something larger or something smaller. It's based on your K, your dilation. Is it going to be larger because it's greater than 1, or is K less than 1? All right, any questions about that? Hey, you're going to use that for when you're graphing the dilations, but also you can use it for this type of problem. So what you need to do is write down, find the scale factor, and then you need to write down how you find the scale factor, which is length on dilation over length on original. And you can graph, and you need to graph this in your graph paper in your notes. So if the original, let's say the original is a small one, and I'm making it larger, okay? What is my K gonna be? Like, is it gonna be smaller than 1, or is it gonna be larger than 1? For an enlargement, it needs to be larger than 1. So whatever I find, I need to make sure that's larger than 1. If you get like a fraction and it was an enlargement, you know you must have done it wrong. So that's something you can use. So to find a scale factor, you take the length on the dilation over the length of the original, which just means you're using the x coordinates. Now you subtract the x coordinates. So this is the original, which what I do is I just pick 2 of the farthest points away from each other, so it'd be those corners. This one's at 3, 2, and this one's at 1, 2. And I go to the dilation. This one's at 9, 6, which it's not fitting there. And then this one's at 3, 6. So when we're taking the length, It just means I'm subtracting the x-coordinates. So if I took the dilation, which is the larger one, what is the x-coordinates of this? I wrote them down. What are they? Not the x-coordinates. All I need is x. To find length, all you need is x. 9 and 3. So I take 9 minus 3. All you do is subtract the x-coordinates. So then the original, what's the x-coordinates for the original? The x-coordinates on the small one. 1 and 3 or 3 and 1. So I do 3 minus 1. What is 9 minus 3? And what is 3 minus 1? 2, which reduces to 3. So there's my answer. My answer is 3. So all we do is we're trying to find out how far are they apart. So I just subtract the x-coordinates. We don't do the y because we're not finding height. We're finding length. So I do 9 minus 3 and I do 3 minus 1. Right? And you can tell there are 6 spaces here. There are 2 spaces here. So there must be, for 1 unit, it must be 3 units. So there you go. Any questions? All right. Here's your homework assignment.